Robot manipulation in unstructured environments has a dual challenge, grasping objects with precision while also absorbing unexpected impacts for contact-rich tasks. In current robotic wrists, control-based solutions typically rely on force torque sensors, which introduce response latency, or use active variable stiffness wrists, which increase system complexity and cost. Our research goal is to develop a passive robot wrist that switches between high-stiffness precision and low-stiffness compliance without any electronics or complex control for household object tasks. As a technical goal, it should support up to 500 grams at the fingertip, limit deflection to under 10 millimeters, and passively absorb large external forces. Based on our goals, the wrist must offer two modes, precision mode and compliant mode. The key is to customize both the critical load and stiffness in precision mode so the wrist changes the mode at the right moment. Introducing BiFlex, a passive bimodal stiffness wrist through the buckling behavior. It features 3D printed top base plates for any gripper, a universal joint for pure buckling, and a TPU lattice that auto-switch stiffness. This honeycomb structure's vertical stiffness and critical load are tunable by modifying the two key parameters. As tilt angle decrease, it increases the vertical stiffness before buckling. As second, higher beam thickness increases the critical buckling load. We customized BiFlex for 3 grippers. Based on each gripper's mechanical properties, we customized key parameters and could achieve different vertical stiffness and critical load for these grippers. To validate contact wrench mitigation across different BiFlex designs, we performed pressing tests where the robotic gripper's fingertip pressed an aluminum frame. All hands effectively limited external forces to below 15 Newton by switching to compliant mode through the buckling effect. To test compliance, we had a Robotiq hand wipe over angled triangular peaks. With BiFlex, it cleared 50 mm hills under 15 Newton, while the rigid wrist hit that limit at just 15 mm, showing BiFlex's superior adaptability and safety. For our pick-and-place test to validate precision performance, we set each shelf space 10 mm taller than the object's height so it could fit with precision mode. BiFlex stayed rigid up to 500 grams and only buckled above that, yet it flawlessly placed every item under 500 grams. Thanks to its compliant mode, BiFlex can exploit the environment, using the table as a guiding constraint to assist with grasping. For example, it can slide along the surface to pick up a hex wrench, even when aimed 50 mm too low, all while keeping contact forces below 15 newtons for safe and reliable pickups. In summary, BiFlex achieved bimodal stiffness for safe manipulation. We demonstrate various tasks to validate real-world performance. Can be used for any gripper by modulating key parameters. For more details, or if you want to build your own BiFlex, please take a look at our website. Thank you for listening.